Welcome back to the online sessions of the practical videos. In today's video, we are going to discuss about the thing that is the operation on the lathe. So what is the main aim? To perform the threading operation on the particular machine lathe, or you can say the lathe machine. Now, what is this threading? Threading is nothing but the curves, helical curves which are given on a particular specimen, that is known as an threading operation. Now, which are the apparatus which we require for this particular operation? The first apparatus, that is the lathe machine on which we are going to perform this particular thing. This is the lathe machine on which we are going to perform our lathe operation, that is known as an threading. The second one which we require, that is the tool, that is known as an V tool. So this is the V tool which we are requiring, as shown over here. This will be your V tool, having a V shape over here. Due to that type, it is known as a V-shaped tool. The main material which we require, that is the workpiece on which we are going to do this particular thing. That means this threading operation on which workpiece we require, that is the workpiece required for this purpose. Now let us discuss about the principle on which our whole lathe machine works. So the very first point comes, whatever the workpiece on which we require a particular machining operation to be performed, that is taken, it is placed under the jaws, 3-jaw or a 4-jaw chuck at the headstock of the lathe machine, and then it is allowed to rotate at a very high speed. Then comes the cutting tool is held at certainly out of one of the position, either on the tailstock or you can place it in the carriage of the lathe machine. Now this tool is allowed to move in any of the directions, suppose parallel or at a certain inclination, perpendicular, any of the motion we are giving it to the tool. So what will happen when this tool, main function of lathe is to, when the tool comes in contact with the workpiece, what will happen? There will be a removal of the metal taking place. And as a removal of this metal, what will happen? We will get our final desirable shape with the help of this thing. So that is the reason why we are taking or we are doing these operations on the lathe. And how does the material remove? The material removal will take place in the form of the chips. So this is how the workpiece is allowed to rotate at a very high speed, and tool is placed in our direction, that is perpendicular, inclination, at an angle, or you can go parallelly towards the workpiece of the sample. So this is how our whole lathe machine works. Next comes the threading operations theory, how this threading operation takes place. In this particular threading operation, lead screw is attached to the carriage on which tool is set. Here, for the only operation by which the threading operation, we will be taking the help of our lead screw. In this type of the operation, this is basically nothing but a semi-automatic thing is done. How we are doing? According to the pitch required for the threading, the speed of the lead is set. Now how does this thing? It is basically this type of the curvature we are going to perform on the workpiece. So it is a semi-automatic working of the lathe is introduced by the half nut mechanism. So when we will attach the half nut mechanism, what will happen? The movement of the lathe will take automatic. We don't have to move any of the, we don't have to give any feed. Automatically the lathe, the lead screw will move our carriage, and due to that movement of the carriage, the tool will be moving, and this is how it will be working. So this is known as a tool which is set over here. This is workpiece. If your workpiece is too large, then tailstock is required. Otherwise, in our practical, we will not be taking the tailstock help, because it is a small type of the sample we are taking. So tailstock is only there for giving the support to the workpiece. So now let us see, this is the thing, these are the threads which we are going to develop on the any of the sample, and this is the tool which is kept. Now, what is the procedure? Why we are using this process? For producing the helical grooves on the external surface. With the help of the V tool or the grooving tool we can take, but majorly we are using the V tool for this purpose. primary motion, that is the rotary motion of the workpiece, is given to this particular sample, and the feed we are always giving longitudinal feed is given to the tool. So this is how the basic concept of the threading operation is told over here. Now what are the mechanism, how we are going to perform it on a lathe? Let us see on the directly practical view that how the adjustment and what are the different types of the parameters which we have to see in the mind before doing the threading operation. So next operation which we are going to see, that is known as a threading operation. You might have seen the threads which are generated onto the sample. Now how this thread we can do with the help of this lathe machine. So for that particular threading operation, what we require a certain type of the automatic of the lathe. That means some portion manual, some automation. So whenever the operation is carried out on the lathe, it will go for the automation, some of the portion. Now how we are going to do this thing? First of all, the first thing, the tool which we require, that is known as a V tool over here, which we have placed over here. So the V tool is placed in the carriage. You can see the edge of this particular tool is of the V type shape, so it is known as a V shaped tool. Now workpiece is always inserted over here at the headstock in the 4-jaw chuck. Now next thing what we require, this is the lead screw. The first time we will be taking the help of this lead screw. This lead screw is used to make the threadings which are done on this particular sample. So with the help of this thing, the automation will be generated. For that we have to require a different arrangement of the gear. What is the first thing which we require? We require the distance of the threads, or you can say pitch of the thread to be done. We require any type of the thing that is of the 1.5 thickness. That means the threading is done about, you can see over here, we require this 1.5 threading. For this 1.5, you can see over here, the combination of the gear will be B and D. So over here we will be doing of the combination B and D, and for that particular thing which we require, lever number 6 is required. So for that, let us see over here, the gears are there. CDEF, over here we have done that in this CDEF we require a D gear, in this we require a particular A and B, out of A and B we require a B gear. So this two combination will be of the B and D. Now second one, what is there? R and F. R, that will indicate of the reverse. Reverse means this whole carriage will be coming in the reverse direction. What is F? F is in the forward direction. It will be going in the forward direction. So this is the particular thing how we will be placing it. So we have seen the arrangement of the gear, how we will be placing over here. Now let us come over here. You can see A and B, and over here the C and D. So here also the combination of B and D lever is to be done. You can see the arrow is over the B lever and this arrow is towards the D lever. This lever is about the engage disengage. Whenever the lever is in engage position, it will automatically go forward. Over here you can see lever number 6 is to be kept, because over here 6 lever is been taken. So over here we will be placing this lever at an 6th position. Before starting, what we will be doing, we will be going for this half nut. We will be taking this half nut engage position. So what will happen, if we are doing with the help of this half nut, we will be engaging, that means it will engage, and as a result of which your whole this carriage is attached towards the lead screw. So this lead screw will automatically move in the direction in which we have kept, either in the reverse direction or in the forward direction. And in that way, one or more times we have to go for this particular same operation, and as a result the thread size of the 15 will be there in the result of this particular operation. So now let us see how it will work and the working of this particular threading operation. This first we will be getting towards the point touching of to the particular sample. So we will touch our workpiece with the tool, and then we will be starting of this particular engagement and that thing. Over here you can see nobody is doing or any operation is carried, but still your carriage is moving in the forward direction. You can see the lead screw also moving. Whenever it will reaches back to its original position, we will change or we will insert some of the amount inside it, and once again the threading has been done. See, once again it will come back from its position. So you can see it is coming back and the operation is carried out. So in this way you can see the threads which are generated onto the sample, or you can say on the specimen you can see, and according to the insert, if we go inside of the material, you can go or you can create more and more inside of the threading. Now let us see what we were doing after each and every pass. So you can come over here and we can see the dial. So there is a dial over here and there is a marking which is done over here. This is our reference point. Whenever the first time your tool is touching your specimen, at that time this dial is coming over here. So after each and every pass we will be moving the 5 portion over here, 2 to 5 portion over here, 2 marks we are moving in each and every step. So what will happen by increasing the 2, what will do, it will go inside 2 parts and then it will do the threading. Once again it will come back. After that we will move once again from 2, we will go for this 4 option. Once again we will be doing the threading. So what will happen, gradually we are inserting the tool inside of the workpiece. Why? Because if we go in a web only one shot, what will happen, your tool will definitely get broken away. Because as in the during the working operation you might have seen the flames coming out, the smoke was coming out, that was because of the overheating. So in this thing the overheating is a problem and it will always be there. So you don't have to go much more inside of the material, otherwise it will break the tool and your whole workpiece will be destroyed. That means it will be of the no use. So in this way, any threading if you want to do with the help of the lathe machine, we can go for this type of the threading operations.